Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge IGCSE Chemistry Paper 2-2 for February-March 2025, and this is part 1 for questions 1 to 20. Question 1. The diagrams show containers of gas at the same temperature. All containers have the same size. Which container contains gas at the highest pressure? Now, pressure is proportional to the number of gas particles that are bombarding the walls of the container. So the more they are, the more the pressure. So our answer here has to be A. As simple as that. So this one is A. Then number 2, a cooling curve for a substance is shown. Okay, which statement is correct? Now, before I even go to the options, between U and V, here we are seeing vapor, okay, or the gas. This is vapor. Then here, the gas is in equilibrium with the liquid. In other words, the gas is trying to condense here, okay? And then Wx, here we are having exactly liquid, okay? Then between X and Y, we are having the gas is in equilibrium with the solid. In other words, the liquid is trying to solidify. Okay, if you are moving this other side, then that means that the solid is trying to melt. Okay, and then here it is totally a solid. So between U and V, option A, between U and V, the substance is condensing. No, condensation takes place between V and W. Okay, then between V and W, heat is absorbed from the surroundings. No, it is not absorbed from the surrounding. It is actually being lost to the surroundings. Okay, it is lost to the surroundings because if the gas is turning to the liquid, then the condensation, so there is formation of bonds, okay, and formation of bonds is exothermic, so energy is lost to the surrounding. So the intermolecular forces of attraction between the particles are being significant. Okay, remember, when they are gases, they are just spacious. You see that? But when they are in a liquid, bonds are being formed in between, so energy is released to the surrounding. So that one is also off. And then we have C. Between W and X, the particles are close together and randomly arranged. W and X, we are seeing it here. It's a liquid only. Particles are close together, yes, in a liquid, and they can slide over each other. They are randomly arranged. So that one is correct. So the answer has to be this C. But let's check D. Between Y and Z, the substance is changing from the liquid to the solid. No, it is already a solid. Question 3. Samples of 4 gases are released in a room at the same time. The gases are carbon dioxide, hydrogen chloride, hydrogen sulfide, and nitrogen dioxide. Which gas diffuses first? So diffusion is proportional to the molecular mass. Okay, so we look at the molecular masses of these ones. The smaller the molecular mass, then the faster the gas will diffuse. Okay, so carbon, you know that it is 12. Okay, then plus oxygen is 2 times that 16. So this one will give us 44. That is the MR of carbon dioxide. In fact, let me write it here. MR of carbon dioxide is going to be equal to 12, then plus 2 times the 16, which will give us 44. Then what is the MR for HCl? This one is going to be 1, then plus chlorine 35.5. So that is 36.5. Then how about hydrogen sulfide? So the MR of hydrogen sulfide is going to be 2 times 1, then plus sulfur is 32, so you will get 34 here. And then nitrogen dioxide, the MR is going to be equal to, nitrogen is 14, then plus 2 times 16. So you'll get 32, then plus 40, plus 14, we shall get 46. Okay, so the one that diffuses fastest is the one that has the lowest molecular mass, and this is the 34. So 34 belongs to hydrogen sulfide. So the answer here is C. Question 4. Sulfur atoms can form the negative ion S2 minus. Then 3 other atoms or ions are listed below. Argon, then calcium, and then the oxide ion. And then they are saying that how many of these atoms or ions have the same electronic configuration as sulfur ion. First of all, sulfur, this one, argon is in position 18. So its electronic configuration is 2 to 8 to 8. And then calcium is in position 20. So its electronic configuration is 2 to 8 to 8 to 2. It's not an ion, it's an atom. And then oxygen is in position 8. So its electronic configuration would have been 2 to 8. Okay? 2 to 6. But it has gained 2 electrons. 2 minus means that it has gained 2 electrons because electrons are negatively charged and protons are positively charged. So you have extra 2 electrons than protons. So this one will be 2 to 8. Okay. Now, when we look at sulfur, sulfur is in position 16. So this is 2 to 8 to 6. Now, sulfur 2 minus, it gains 2 electrons and it will be 2 to 8 to 8. Okay. So the electronic configuration here has to be the one for argon. Okay, so how many of these atoms or ions have the same electronic configuration as sulfur, as a sulfide? So it has to be B here. It is only one, which is this argon. Okay, then number 5, element T has 2 isotopes. We have 12,6 and then 14,6. And then they are saying which statement about these isotopes is correct. First of all, the proton number is the same. So they should be having the same chemical properties because the number of outermost electrons are equal. Then they have, these mass numbers are different. That means they have different number of protons. So let's look at the options given here. They have different chemical properties? No. They have the same because they have the same number of what? Protons. And what determines the chemical properties are the number of protons in the nucleus. In other words, the electrons actually in the outermost shell. Okay, we call them the valency electrons. I can talk about this in terms of protons and or maybe electrons because isotopes, we are looking at atoms of the same element with the same proton number but different mass number. We are not talking about electrons. I mean ions. You see, they are atoms of the same element. So they will have the same chemical properties because they have the same outer shell electrons. So part B, they're saying they have the same chemical properties because they have the same number of outer shell electrons. Those are the ones we call the valence shell electrons. How many electrons are donated? How many electrons are transferred? Let's say maybe that is ionic bonding, and then how many are being shared. Okay, so the answer has to be this B. It's about those chemical properties which are due to the same number of outermost electrons. But when you look at C, they have the same nucleon number because the sum of the number of protons and neutrons, electrons is the same. Nucleon number is the same as addition of the number of protons and neutrons. Okay, not electrons. They have different positions in the periodic table? No. The fact that they have the same proton number, then they are in the same positions. Then number 6, lithium is in group 1 of the periodic table. Nitrogen is in group 7 of the periodic table. Lithium reacts with nitrogen to form the ionic compound lithium nitride. What happens to the electrons when lithium atoms and nitrogen atoms react? Lithium is a metal, so it reacts by losing electrons, okay? And then nitrogen is a non-metal. It reacts by gaining electrons. So let's look at the options. Part A, each lithium atom loses one electron to form a lithium ion here. That is true. It is in group 1, so it forms lithium 1. Okay, let's check the one for nitrogen. We have each nitrogen atom gains 3 electrons to form a nitride. And that is true. Becomes a 3 minus, because if it has gained 3 electrons and electrons are negatively charged, then it is going to have that negative charge. So that means the answer here has to be A. Question 7. For which covalent compound does the dot and cross diagram correctly show the outer shell electrons? We have hydrogen chloride, we have this, and then we have the one for ammonia. Now, for hydrogen chloride, we know that hydrogen has 1 electron in its outermost shell. So you cannot say that it has 2 here, and then also, in fact, here they are showing that it has 3 here, and then it has bonded with 1 of chlorine. So this one is already off. And then when we go to B, same thing. It has to be 1 electron. So this one is also off. Here it has 1 electron, yes. And then it has shared with nitrogen. Nitrogen is in position 7. So its electron configuration is 2 to 5. Okay. So it has 5 electrons in the outermost. These are 2, 3, 4, and 5. Yes, it has shared with 1. 1 with all the hydrogens here. And that is actually correct. Ammonia has what we call a trigonopyramidal shape. Okay, trigonopyramidal shape. These ones, you will study them in A level. You will understand them better. What we call the valence shell electron pair repulsion theory. Okay, that's what we use when we are explaining this. The lone pair bond pair repulsion is bigger than the bond pair. You see? But then when we come to this one, they are giving us 3 electrons of nitrogen, and yet it must have 5 of them. Okay, so meaning that our answer has to be a C here. And then next, number 8, they are saying that which row identifies the positive and the negative particles present in a giant metallic lattice. A giant metallic lattice has positive, okay, or we can say cations, positive metal ions in a sea of delocalized electrons. There is a regular pattern for those positive metal ions. Then in a sea of delocalized, the electrons are delocalized, they are free to move. Okay, so positive particles, they must be cations, and then the negative particles, they are not anions, they are delocalized electrons. So that means our answer here is going to be a D. Next, question 9. They are saying that which formula for the named compound is correct? Calcium oxide. Calcium is in group 2. It is in position 20. Okay, so we have 2 to 8 to 8 to 2. Oxygen is in position 8. It is 2 to 8. No. It is 2 to 6. So this one requires 2 electrons to have a full octet. You see that? So that means it is going to form a charge of 2 minus. And then this one loses the 2 electrons, then it will form Ca2 plus. Okay, these 2 will cancel out, and then because this is a plus 2, this is a minus 2, so they just cancel out. So for 1 calcium ion, we shall need 1 oxide ion, then we shall form the calcium oxide. So this one is correct. Cobalt 2 chloride, it has to be cobalt. Chlorine is in group 17, so it needs 1 electron. Not group 17, it is group 7. You know, in A level we say group 17. Okay, so here chlorine is in group 7, so it needs 1 electron to have a full octet. So therefore it is in valency 1. Okay, it must form that one. Now for these transition elements, when they say cobalt 2, because they have variable oxidation states, the one that they mention in the brackets is the one that we take. Now, this one is a 2 plus. Now, that means to balance this 2 plus, you will need 2 minuses. Do you see that? 2 minuses. Such that you get cobalt is 1, but chlorines are 2. So cobalt 2 chloride has to look like that. You see? And then, what else? Sulfur dioxide. Sulfur dioxide is just like this. Anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate. A sulfate has this ion, 2 minus. Copper 2, which is 2 plus. So these two charges are balancing. So meaning we shall have copper 2 sulfate written like this, not like this. So that's why our answer is A. Question 10. The equation for the reaction of magnesium with dilute sulfuric acid is shown. We have magnesium plus sulfuric acid. Then we get magnesium sulfate plus hydrogen. The relative molecular mass of magnesium sulfate is 120. Which mass of magnesium sulfate is formed when 12 grams of magnesium completely reacts with dilute sulfuric acid? Now, we shall begin by finding the moles of magnesium. Okay, so magnesium is 24. So we shall have, this is 12, then out of 24, which gives us, these are the moles of magnesium. This is the same as 0.5. So when you look at this stoichiometric equation, here there is 1 mole of magnesium reacts to give 1 mole of magnesium sulfate. So meaning if here we are having 0.5 moles of magnesium, even here it will be 0.5 moles of magnesium sulfate. So what mass of magnesium sulfate is formed? Then we are going to have, you know that moles, the number of moles is equivalent to mass out of the MR, the relative molecular mass. That means if we are to find mass, then mass is equivalent to the number of moles, then times the MR. Okay, so we shall get the mass here by getting the number of moles, which is 0.5, then times the MR, which is 120. A half of 120 is, of course, 60 grams. So the answer for number 10 has to be a C. Question 11. An organic compound Q contains carbon, hydrogen, and oxygen only. Q contains 40% carbon and 6.7% hydrogen by mass. What is the empirical formula of Q? So first we need to get the mass of oxygen. Okay, mass of oxygen here is going to be 100, then minus 40 here plus 6.7. That one will give us 46.7. 46.7. And then this one will give us actually 53.3. So meaning I will have my carbon, then the hydrogen here, and the oxygen as the elements. Then the number of moles, the percentage by mass of carbon is 40, then divide by the AR, which is the relative atomic mass of carbon, which is 12. And then the mass for hydrogen is 6.7. I will divide by the AR of hydrogen, which is 1. And then oxygen, we have 53.3. Then we divide by 16 here. So 40 divided by 12 by 410, then by 43. So this will be 10 over 3, which is actually the same as 3.3 recurring. And then this one will give you 6.7. Then how about 53.3 divided by 16? 53.3 divided by 16. That one is 3.33125. 3.33125. Then we shall find the mole ratio. You get the smallest, you divide it all through. This is 33125. This is 33 recurring. So the smallest is this one here. We shall have 3.33125 divided by 3.33125. And then here 6.7 over 3.33125. And then 3.3 recurring divided by 3.33125. This one has to be 1. which is approximately equal to what is up. Then this one is 2, because when I multiply this one by 2, it will be 6.66, which is approximately 6.7. And then this one is 1. So meaning our empirical formula is going to be CH2O, which is answer B. Question 12. The value of Avogadro's constant is 6.02 times 10 to power 23. What is the total number of atoms in 2.00 moles of ammonia gas? Now, ammonia has 4 atoms, NH3, 3 hydrogens, and then 1 nitrogen. If they had asked about the total number of moles, the total number of, let's say, molecules, because the Avogadro's constant can represent the number of particles. The number of particles can be atoms, they can be ions, they can be molecules, okay? So here they are talking about atoms, the total number of atoms. So we are going to look at the nitrogen, then the hydrogen, 3 of them. Now, 2 moles of ammonia gas. If we have 2 moles of ammonia gas, 1 mole of the molecule is the one that contains these 6.02 times 10 to power 23 ammonia molecules. Okay, now we have 2 moles. That means the number of atoms are going to be 2. First of all, those are 2 moles. Then times the number of atoms we are having here are 4. Okay, so we shall say times 4, but then times this number 6.02 times 10 to power 23. So which answer do we get? 2 times 4 times 6.02 times 10 to power 23. That is 4.861, which is approximately 4.82 based on our answers we are having. So that means 12 is C. C. Question 13. 3 aqueous solutions L, M, and N are electrolyzed using inert electrodes. L is concentrated hydrochloric acid. Okay. Now, usually concentrated hydrochloric acid has some little amount of water. Okay, because we bubble hydrogen chloride into water to form hydrochloric acid. So these are the ions which are present there. We are going to have hydrogen ions and chloride ions. We shall also have hydrogen ions and OH ions, which are coming from water. Okay, then concentrated aqueous sodium chloride, we shall have hydrogen ions, and then we shall have sodium ions. Then the negatively charged, we are going to have the chloride ions, and then the OH ions. Okay, remember this and this, they are from water, then sodium chloride. So since this one is concentrated, then we have more of these. Okay, no. We have more of these ones here, sodium chloride, rather than these ones here. Okay, so also here for the first one, the ones that I'm going to put to circle out are the ones that are in plenty. So for concentrated, then we are going to have these ones here from the acid, okay, rather than these ones from the water. Then N is dilute sodium, aqueous sodium chloride. So we still have the sodium ions, we have the hydrogen ions, then this way we have the OH ions from the water, and then the chloride ions. So aqueous, that means we have more of the water molecules. So these ions are more. Now, which solutions produce a pale yellow gas at the anode? Pale yellow gas is the chlorine. Okay, the pale yellow gas is the chlorine. Now, chlorine is going to be produced at the anode where the solution is concentrated. So it has to be for L and this one here, L and M. But if the solution is dilute at the anode, what is going to be discharged is this OH, so oxygen will be produced from there. Okay, for a dilute solution, we get hydrogen produced, okay, hydrogen gas produced at the cathode, because the positively charged go to the opposite, the electrode with the opposite charge. Okay, so what is positively charged goes to the cathode, which is negatively charged, and then what is negatively charged goes to the anode, which is positively charged. Okay, what is negatively charged goes to the electrode, which is positively charged, the anode. So we must have L and M, and that is option A. Question 14. Dilute sulfuric acid is electrolyzed using inert electrodes. What are the ionic half equations for the reactions that take place at each electrode? Okay, dilute, just like I've said, dilute here. We are going to see hydrogen going to the cathode. Then we have the OH going to the anode. Okay, so for the anode, you are going to have your OH there, and then this one is going to give off the oxygen and water. Okay, oxygen and water. Then we shall have plus electrons. How many are they? Because for us to get this oxygen here, oxygen is losing the charge here. It is charge -2, but then here for the element, it comes out as 0. So this is what we call oxidation, okay? Loss of electrons. Now, if we are to balance this one, I can put here a 2, then hydrogen becomes 4. Okay, if it becomes 4, then I will put a 4 here. But do you see that oxygen is also 2, then plus the 2 here, which is 4? Now, to balance our equation, I'm going to put 4 electrons this way, because this is 4 minus this way, and this is 4 minus this side. Okay, so in ionic equations, we also balance the charges. So I have to look for this equation here for the anode, the positive electrode, which is where? You see, this one is wrong. So it is this C here. C. It's the one that is giving me the right one here. So let's check what is on the negative electrode. So at the cathode, hydrogen goes there, and then it receives electrons. Then it becomes hydrogen as a gas. So to balance this, I'll put 2 here, and then a 2 here. So the 2 minus cancels the 2 plus, but hydrogens are 2. Hydrogens are 2. You see that? So that is why we are having this one also correct. Okay. Then number 15. Which statements about hydrogen-oxygen fuel cells are correct? They convert chemical energy into electrical energy. That is true. Then next, hydrogen is reduced in fuel cells. No, it is actually oxidized because one of the products is water. There is addition of oxygen onto the hydrogen. So this one is wrong. But then when you look at 3, they do not produce any atmospheric pollutants. That is true, because water is the waste what? Product. So our answer has to be on 1 and 3. Where is it? C. Question 16. The reaction pathway diagram for the reaction between P and Q to form R and S is shown. Which letter represents the enthalpy change for the reaction? Enthalpy change of the reaction, we see the difference between the 2 lines, the one for the products and then the one for the reactants. So you look at this one here and then the one here for the products. So it has to be this C here. Okay, and it is facing up. This is positive, so it is an endothermic reaction, meaning the system is taking in energy, so the products are going to be of higher energy compared to the reactants, you see? So the arrow has to be facing up. But where you are having the energy level diagram like this, where you have here reactants and then here the products, then the arrow is going to face down here. Okay, and that is exothermic. The system is losing energy to the surrounding. That means the energy which is left in the products has to be very small. So that is why the products happen to be on a lower energy level. Okay, so our answer there is C. Then 17. The equation for the complete combustion of methane is shown. It is here. The table shows some bond energies here. What is the enthalpy change of this reaction? So the enthalpy change is equal to enthalpy change, we denote it with dH, is equal to energy in minus energy out. Or I would say the energy of breaking the bonds plus the energy of releasing, plus the energy of forming the bonds. But bond formation is exothermic, and exothermic reactions are having a negative. You see that? So that's why we just put here negative. So the energy in, this is endo. Energy in, you are putting in energy, but then energy out, you are releasing the energy to the surrounding when you are forming the bond. So this one is exo. Okay, so let's look at what is here. We have methane. Methane, there are 4 hydrogen, which is in a tetrahedral shape like this. Then we have oxygen, linear, double bond. There are 2 of them. So I'm going to represent them like that. And then this other side, we are having carbon dioxide, which is linear. And we also have water, which is bend-shaped like this. You don't need to know these shapes now. You'll get them later in A level. Now, so energy in is for breaking these bonds. We can see the C to H bonds here are 4 in methane. Okay, so I'll put 4 here times, that is 410. 4 times 410. Then plus, we also have these ones here. There are 2 of them. Okay, so this one here is 496. So I'll say 2 times the 496. Then I'll subtract energy out, formation of this bond. So carbon to oxygen double bond, there are 2 of them here. One is here, another one is here. So we are going to have, they are here. So it will be 2 times 805. Then subtract, what do we have here? Oxygen to hydrogen. This is 1, this is 2, this is 3, this is 4. Oxygen to hydrogen single bond, 460. So we shall have 4 times 460. So when I put all of this in the calculator, what do I get? 4 into 410 plus 2 into 496, then minus 2 into 805 minus 4 into 460. I've opened the brackets, okay? When you open the brackets here, the 4 is going to become a minus, okay? So we shall have negative 818. Negative 818. These are kilojoules per mole. So it has to be where? It has to be B. Question 18. Which change is a physical change? Now, in a physical change, no new substance is formed. No new substance is formed. So in other words, it is a reversible reaction. What you form, you can easily reverse it. Okay? When you change a few conditions. Cracking of an alkane. When you crack an alkane, this is a process of breaking down, okay, a long chain alkane to smaller chain alkane and also alkenes. So it can give us smaller alkanes and alkenes. We can also have alkenes only and hydrogen, you see. So now, don't you see that here there is a new substance formed? there is a smaller alkane, and there is a new alkene. So this one is not a physical change, it is actually a chemical change. Evaporating ethanol. Anything evaporated can be cooled, can be condensed back to that liquid. So B, let me first mark B. Okay? Fermenting glucose. When you ferment glucose, you actually get ethanol. One of the processes of obtaining ethanol is fermentation of glucose. Neutralizing an acid. Neutralizing an acid, here you are reacting an acid with a base. Then you form a salt and water. Okay? You see that? You form a salt and water. So these are new substances formed. So, and also ethanol here is a new substance formed from the glucose. So our answer here has to be B. Question 19. Which statements explain why increasing the temperature in a reaction involving gases increases the rate of chemical reaction? When, of course, you increase the temperature, these particles are going to gain energy. So their kinetic energy is going to increase. They are going to move so fast. Then they will be colliding more often. That is what we call the frequency of collision becomes much more often. Okay, so we are using here the collision theory. So we are going to have, they are giving us the conditions here, what is happening. So which statements explain why increasing the temperature in a reaction involving gases increases the rate of a chemical reaction? Number one, it increases the collision frequency between the gas particles. That is true. It lowers the activation energy. No, activation energy is never lowered. Okay? Even when you add the catalyst speeds up the rate of a chemical reaction by providing a pathway with the lower activation energy, but it has not removed the initial barrier. You get it? It's like when you are getting a passport, okay, from the passport's office. When you go there, because you know someone in the passport's office and you want to get the process very fast. So when you call them, they will tell you, okay, fine. You submit your papers. When you're submitting the documents and everything that is required, and there is a fee that they put there that you must pay, and you pay it. So the moment you submit your documents, when they will be checking through the files, they will get your file very fast, and then they work on you, and within a few hours or a few days, you get your passport, right? But if you don't know someone, it is going to take the usual process. You might get your passport in a week, just like that. But it has not removed the fee that you're supposed to pay for the passport. Do you get it? So that is the barrier, the activation energy. So you knowing someone in the passport's office is a catalyst to speed up the process for you to get the passport. Do you get it? So a catalyst never lowers the activation energy. It just provides a pathway with the lower activation energy. Then number 3, it increases the kinetic energy of the gas particles. Of course, that is okay. It increases the number of gas particles per unit volume. No, when you heat, the particles are just gaining the energy and they are moving fast. So these particles are going to have energy that is higher than the activation. Many particles are going to have the energy that is higher or equal to the activation energy required. So that's why they can result into the successful collision. So you can see that I've ticked 1 and 3, and therefore the answer has to be A. Then question 20. The equation for the reaction between ammonia and oxygen is shown. It is here. And the enthalpy change is a negative. So it is exothermic. That means when you increase the temperature, it will favor the backward reaction. Okay, because when this one is negative, then it is the forward reaction that is exothermic. Then the backward has to be endothermic. Okay. Now, they are telling us that which two changes to the reaction conditions will both move the position of equilibrium to the right. So, to move the position of equilibrium to the right, remember here we are using the Le Chatelier's principle, which states that if one or more factors affecting the rate of a reaction at equilibrium is altered, then the equilibrium position shifts to the side that opposes the change. Okay, you have taken out this one here, so more of this is going to react to bring back what you have taken out. Now the equilibrium shifts to the right. You see that? Now, let's look at this 20 here. So the changes that are given here, increasing the temperature. Remember, we are shifting the position to the right. When you increase the temperature, you will shift the position to the left. Why? Forward reaction is exothermic. So A is off. Now B, increasing the temperature. Again, whatever is here is wrong. We don't even need to look this side. Then C, decreasing the temperature. Yes. How about change to increasing the pressure? When you increase the pressure, pressure is inversely proportional to volume. That means when you increase the pressure, volume has to reduce. So how do we interpret this using what we are having here? Pressure is directly proportional to the number of gas moles present. The more the gas particles, okay, the more the frequency of bombarding of these particles on the walls of the container. So more pressure is exerted with more number of gas moles. You see that? Okay, then when we look at here, the total number of gas moles here are 9. Okay, and then the total this way, they are 10. Okay, so when you increase the pressure, the position of equilibrium is going to shift to the side with less moles. I want you to look at a class where you are very many in class, okay? And there is a lot of noise there. Then they happen to open another room next to you. If you need comfort, you are going to shift to that room. That is the position of equilibrium changing. You see that? So this one will shift to the left. Because you have increased the pressure, volume has to reduce. So the equilibrium position is going to shift to the side with less number of gas moles. And less number of gas moles, we see it here. The more is this side. You see? So this one has to be wrong. And then our answer has to become this D here. Okay? So the answer is D. You decrease the temperature, you favor the forward because it is exothermic. You decrease the pressure, then the equilibrium position will also move to the side now with more gas moles. You see? So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.